start looking at our first example for a problem that deals with exponential growth or decay. So in my example 1 right here, I am going to show the problem. So in 1970, the US population was 203.3 million. By 2007, it had grown to 300.9 million. Okay, so that is generally the information that we have so far. Okay, so now the first question for this problem, see, find a function that models the data for 1970 through 2007. So this is, once again, it is just, see, like I told you earlier in the general discussions, this is one of the common questions that we are expecting, right? So technically, we are supposed to look for something like this. Like if A here is our population at any time, right? We want to come up with some kind of so a sub 0 times e to the kt like that, right? We need to come up with a function that looks generally in that form. And so now what I need to know is I need to find out what my initial population is, and I need to find out what the k is. I need to find the k. So k and a sub 0 are the two parameters that I need to find out through my data given in the problem. Okay, so I'm gonna go ahead and switch over to my document camera right now, and then we're gonna start looking at the problem. So, and I assume that you have already paused the video and have written down the question itself, so that I don't have to keep switching back and forth to the problem. Okay, so in the way I see, so once again, what we want, right? The goal here is to complete, right? To complete the functions. The function a equals a sub 0 times e to the kt. Okay? So a sub 0 here, once again, and mainly we need to find a and k right here. Okay? We need to find a sub 0. And we need to find okay. Alright, so in my problem, what do I know? In 1970, it looks like in 1970 is the time where we start our experiment, right? When we start measuring the population. So you can consider that. So now, quickly, a sub 0 now, in our problem here is actually 2.03.3 million. See, once again, for the reason being, because in the way how the problem is stated, 1970 is the starting point, right? Is the initial point, the starting point of the problem. And so at that time, we do know that population was 203.3 million. So this is going to be our initial population. So you can rewrite the equation a little bit. You can rewrite the functions as 203.3 times e to the kt, right? So we one step closer to the answer now. Okay, so now the remaining job here is to find k, right? Okay, k is left to find. All right, so now what I need to do next is I know that, so the thing is, okay, t is going to be now, t, remember, is the time it takes, right? The time it takes to reach, to a certain population. So now look at it. In our problem, it looks like we're starting out with 1970, right? That's where we're starting out our problem. But then we end the problem at around 2007. So the total amount of time here is that in all these years, how much time does it take? That would be what, 37 years, right? So t here is 37 years. So t equals 37 years. Okay, so we found one further clue here. So indeed, at this point here, I am actually ready, right? So now at the starting point, initial population was at 203.3 times e to the kt, right? And I still don't know that parameter k yet. But then in 37 years after, right? In 37 years later, the population here is, so when t, okay, when t equals 37, right? Then A, which is the population at the time 37 years later, is actually 300.9 million. Okay, so that means I can make use of all this information right here. I can plug all this information right here, the t value, the A value here, into the equations, into that equation for A and for t there. So what I have is 300, substitute for A on the left side, 300.9, right, equals 203.3 e to the k. Now t is to be substituted by 37. Okay? And so now at this point now, what I can do, all I need to do is solve for k, right? We need to solve for k. Okay? Alright, so now the way to do that. Now remember, the equation is actually we have brought back to the equation 203.3 e to the 37k, right? Let me rewrite this. 203.3 e to the 37k, right, equals 300.9. Okay? Now this, I hope you recognize this equation right here is an exponential equation. It's an exponential equation. So, and it's base e right here, base e. So the way to do that, we just simply, first of all, I'm going to divide both sides here by 203.3. 203.3. And so I'm going to end up with e to the 37, e to the 37k, okay, equals 300.9 over 203.3. Okay? And then so, to solve for k now, all I have to do is just, now remember, 37k equals to natural log of the right side, 300.9 divided by 203.3. Okay? That, remember, this is the trick we went over in class, right, of how to solve an exponential equation. And so now, at this point here, all you have to do next is to solve for k. Of course, you need to compute what's going on the right side here. You need to use your calculator and punch it in and compute the right side right here. But then k now at this point here, all you have to do is divide both sides by a 37. Right? Divide both sides by a 37. So your k value here is to be determined by ln of 300.9 over 203.3 and all divided by 37. Yes, I do agree, it's a big number, it's a big quantity to compute, but then your calculator should be able to handle it. Right? So, in my calculation, okay, I am going to have, okay, so give me 1 second here. Do a calculation quickly. Okay, so my calculation shows that the k value here is always, is for this problem, the k value here is 0.011. Do expect that k is a small value. Okay, so this is my k. So what am I going to do with that k? I'm done. My function. So the function, right? The function at this point is going to be at any time the population in any year, right? At any time the population is equals to 203, which is the initial population, times times e raised to the power of 0.011 t. That is my function that models the exponential growth for the US population according to the information given in this problem. Okay? So now, we are done with part A of that example, right? So let's move on to part B of the example. So let's look to see what's the example in part B is like. Okay. So now, if I switch back to my PC mode, okay, so the question is asking for, alright, so the next question is, by which year will the US population reach 315 million? See, so this is the kind of another, it's the other, one of the common questions that I gave you as a list before, right? We want to specify 315 million for population. So we are asking for how many years, right? How many years later on? Is it going to reach to that, population? Is it going to reach that particular population? So really, all you have to do now is you're going to solve for, you're going to plug that 315 right here. You're going to plug 315 back into the equation. So now, this is our function right here, right? Our function here is for part B of the problem, right? Our function is 203.3 e to the 0.011 t, right? So now, I want to find out how much time that is. So, and I want, my expectation here is that I want my population to be 315 million. So I'm going to plug 350 million into the left side, substitute for A, and then my right side is, everything is the same. 203.3 e to the 0.011 t. Right? And then I'm going to solve for an equation again. And this is once again another exponential equation to solve. Okay? So what I do, next thing, divide both sides by 203.3. Okay? 203.3. So I'm going to end up with e to the 0.011 t. Right, equals 315 over 203.3. Okay, and so that is going to give me, so to solve for t, 0.011 t is equal to natural log. We're taking the natural log of both sides, right? We're taking the natural log of both sides, and then that's going to be 315 inside the log, 203.3. Right, and then to solve for t is equal to, I'm going to just simply divide both sides by 0.011. Right? 0.011. So my t value here, my t value is going to be natural log of 315 over 203.3, and all divided by 0.011. Okay, once again, in my calculations, okay, in my calculations, let's see what's happening. Okay, so we have 315 divided by 203.3, okay, and then taking the natural log, okay, and divided by 0.011, okay, and that gives me 39.85 years. Okay, so, but then it's not exactly, they're asking for how many years it takes. It's asking for what year that is to reach that much. So you actually have to add this number to 1970. You take 1970, you add with 39.85. Okay? Or which is, so that's going to be approximately, rounding it up, it's going to be in 40 years later, right? So that's going to be in 2010. And that is going to be, so in year, okay? So that's going to be the year 2010. That's going to be when we reach, the US population reaching 315 million people. Okay? And that is the answer to our example.